Hi friends, in this video we are going to discuss about slip test. So by conducting slip test we can find xq and xt values of salient pole synchronous machine. Let's see, I am taking a two pole salient pole machine. This is like this, and here generally this should be connected to excitation, but during the slip test this is open circuited. And a high resistive voltmeter connected across the field winding and a reduced three-phase AC supply. What is that? This is a reduced three-phase AC supply given to the armature, and the rotor should be rotates at some speed is called NR, which is this NR should be less than synchronous speed in order to maintain the slip. Here slip speed is nothing but ns minus nr. It should be there. What happens are here field winding is open circuited and connected across a high resistive voltmeter and reduced three-phase AC supply given to the stator. When the reduced three-phase AC supply given to the stator, then it produces rotating magnetic field which rotates in clockwise direction with some speed is called synchronous speed. Then after, the rotor is rotating by using prime mover with less than synchronous speed in order to provide the slip. Right? This is the conducting slip test. Why we have to give the reduced three-phase AC supply? To avoid the armature current problems. It may lead to more armature current which damage the machine. And why we have to open circuit this? Same. And why we have to rotate the rotor with less than synchronous speed in order to maintain the slip? Then only we can get the accurate results. Actually, to get the accurate results, the NR, the rotor speed should be very close to NS, but not equal. This is very important. To get the better results, the NR should be very close to NS but not equal. Then we can get the exact accurate results. And next one, actually here the poles are rotating with some speed. This axis is taken as a D axis and other axis is taken as a Q axis. When the stator poles and this rotor is coincides, that is taken as a D axis and other axis is taken as a Q axis. Actually there is no poles in our rotor because this is open circuited. But here the stator poles are there, north pole and south pole, which rotates at synchronous speed. This is taken as a D axis. When this axis, this north pole south pole axis coincides with this rotor, that is taken as a D axis. Then other is taken as a Q axis. When that is coincides with the D axis, when those poles coincides with the D axis, what happens here? Air gap length is less. If air gap length is less, is nothing but what happens, sir? If air gap length is less, nothing but the reactance XD value is more. The XD value is more. I said you already, along the D axis the XD is greater. When XD is more, then the current along the D axis is less, the ID is very less, and the voltage across the armature. Actually here we have to connect one voltmeter and one ammeter. The ammeter reading is less and the voltmeter reading is more. Voltmeter reading is more at this condition when this is across the d-axis. Across the d-axis, the voltmeter reading is more and the ammeter reading is less. Whereas along the q-axis, when it is coincides with q-axis, air gap length is more, then the reactance is less. As usually at this condition, the voltage is less and the current is more. The ammeter reading is more and the voltmeter reading is less. Armature, voltmeter reading and ammeter readings. At this condition, we have to observe these points. Nothing but how it is actually if you draw a graph for this, for example, this is for voltage and this is it okay? Okay. And this is for current. For example, I'm taking somewhat upwards. This is for current. Here I am taking voltage and here I am taking current. When it coincides with the d-axis, voltage is more. When it coincides with after d-axis, we have a q-axis. When it coincides with q-axis, the voltage is minimum. When coincides with q-axis, voltage is minimum. When again d-axis, voltage is maximum. When again q-axis, voltage is minimum, like this. When here along the d-axis voltage is maximum, but current is minimum. And here current is maximum, and here current is minimum again, and here the current is maximum, like this. So like this we have a overlapping, like this we have a overlapping, like this, overlapping. The wave shape is called, right? So this is the current and voltage waveforms. Here when we complete one d-axis and one q-axis, when we completed one d-axis and q-axis, one cycle completed, nothing but it gives one EMF wave, and it gives one EMF wave. This is the EMF waveform. Nothing but the frequency of EMF waveform is equals to, see here, this is my EMF waveform. The frequency of EMF waveform is only 50% of frequency of voltage, or only 50% of frequency of current fluctuations. The frequency of EMF is equals to only 50%. See, this is only one time, but here the voltage is 2 times. Like that, you have to remember in this test. And from this test, what is the value of X? X is nothing but V upon I, nothing but VD ID, and XQ is equals to VQ IQ. But what is the exact formula for XD? XD is equals to VD. VD nothing but V maximum or V minimum? VD nothing but V maximum upon, what is ID? Minimum or maximum? ID nothing but minimum. So XD is equals to V maximum I minimum. XD is equals to V maximum I minimum, and XQ is equals to V minimum upon I maximum. V minimum upon I maximum. These are the formulas, very, 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 very important for competitive exam. These two formulas are very important. Actually, for those two formulas only, we are conducting the slip test. Only for these two formulas. Is it okay? Right? So, along the d-axis, the reactance value is more. When reactance value is more, the voltage drop also more. When reactance is more, voltage drop is more. When reactance is less, the voltage drop is less. Voltage drop across the armature. The voltmeter reads that voltage drop across the armature. When reactance is more, voltage is more, voltage drop. When reactance is less, voltage drop is less. And here current is less and here current is more. Based on that, we calculated XD and XQ values. This is very simply the slip test. They will ask you questions like this. They will ask you questions in competitive exams. How they will ask you? Very simple. For example, a slip test conducted on salient pole machine, voltmeter and ammeter readings, 100 volts, 200 volts, 10 amperes, 20 amperes. Slip test conducted on salient pole machine, voltmeter and ammeter readings, 100 volts, 200 volts, 10 amperes, 20 amperes. Then find XQ and XD and difference of those two. Like that they will ask you. What is saliency? Like that they will ask you. Or simply they find XQ and XD. What is XQ? XQ nothing but V minimum upon I maximum. What is V minimum? V minimum is 100 and I maximum is 20. The answer is 5. As usually, what is XD? XD, tell me the answer. Tell me the answer. Hold the video and tell me the answer. Very good. V maximum is 200. I minimum is 10. So the answer is 20. This is 5 ohms and this is 20 ohms. XQ is less than XD always. Always XQ is less and XD is more. Like this, we can find the XQ and XD values by conducting the slip test. Is it okay? Understood? Thank you.